This video investigates whether AI large language models, or LLMs, can successfully solve problems in engineering statics. LLMs improved exponentially in 2025, so this project tested these new capabilities to solve statics problems. The quick answer is that Gemini 3 Flash and Qwen 3 thinking perform exceptionally well and are correct at least 93% of the time. DeepSeek R1 and Claude Opus 4.5 are okay, while many models did not perform well at all. This video will cover the models tested, the model results, and comparisons. The full dataset of 68 engineering statics questions covering all statics topics is provided at the end of the video. The models tested included a mix of open and closed access models, including GPT-OS 120B, Gemma 327B, DeepSeek R1, Qwen 3235B Thinking, Llama 3.370B Instruct, Minimax M21, ChatGPT 5.2, Claude Sonnet 4.5, Claude Opus 4.5, and Gemini 3 Flash. All models were accessed between January 26 and 29, 2026. Open models were accessed using Hugging Face via Python script and API. The closed models were accessed online, directly from the model's webpage. Gemini 3 Flash was the top performer with 96% total accuracy for the 68 questions, closely followed by Qwen 3 Thinking at 93%. DeepSeek R1 and Claude Opus 4.5 also scored well, at 85% and 81% respectively. The smaller models did not perform well at all. The best open model was Qwen 3 Thinking. This slide compares the top 5 models. Trusses, frames, and beam internal forces are the more difficult topics in engineering statics, due to the substantive calculating and reasoning required. Gemini 3 Flash and Qwen 3 Thinking performed strongly on these topics, with 80% or higher accuracy. Other models struggled in these difficult areas. All statics questions were sourced from the open-source textbook, Engineering Statics, open and interactive. Because the questions utilize dynamically generated variables, it is unlikely that the specific numerical values were included in any LLM training data. All questions were manually converted to text-only prompts. The following slides show some exemplar problems from the different topics. Note that the LLMs were prompted with the text-only version of the problems provided at the end of this video. Here are some particle equilibrium problems. The problem set also included problems involving moments and force couples. Rigid body equilibrium was another important topic covered in the questions. Trusses problems were also included in the dataset, where either the method of joints or sections is required. These are challenging from a reasoning standpoint, since internal forces and their correct signs need to be carefully managed. The dataset contained various frames problems, some with multiple different types of loads. Questions on centroids were part of the problem set. Questions requiring the calculation of beam reaction forces were part of the problem set. Problems related to beam internal forces are also quite challenging. Some questions required the calculation of maximum or minimum values, while many required the calculation of the full shear and bending moment diagrams. The dataset included several friction problems. Finally, some questions on moments of inertia were included. In summary, the full list of typical engineering statics topics was covered. The final slides provide the text prompts of the questions exactly as they were provided to the LLMs. The answers are also provided here for the viewer. Obviously, these were not given to the LLMs. There was also a system message provided to the LLMs defining sign conventions. Positive x-axis is right. Positive y-axis is up. Positive internal forces on an incremental element are shear force upwards on the left side of the element, shear force downwards on the right side of the element, moment clockwise on the left side of the element, moment counterclockwise on the right side of the element, and normal force outwards on both sides of the element. Also to use 4 significant figures. I am currently working on the next installment, which will test how good LLMs are at engineering mechanics problems, so check back here soon.